The North American solar eclipses were spectacular for everyone to witness, and for scientists they presented a unique opportunity to collect data about the Sun and Earth. But there's a challenge. The moon's shadow races across Earth at thousands of miles per hour, and in any one location, a total eclipse only lasts a few minutes. By recruiting participatory scientists across the country and spreading them along the eclipse path, their combined observations of the complete eclipse view can be stretched to over an hour. Everyone you'll see in this film is a participatory scientist who helped support eclipse research investigations. Many of them are participating on a volunteer basis. Anyone with a passion for science can become a participatory scientist. In this episode of Science Through Shadows, we'll follow two projects related to recent eclipses in North America and feature the contributions from their participatory scientists. Run by Montana State University, the Nationwide Eclipse Ballooning Project focuses on studying how our atmosphere responds to the sudden blocking of sunlight caused by a solar eclipse. The project supported 53 teams launching high-altitude balloons during both the 2023 annular eclipse and 2024 total eclipse. What does it take to carry out this type of research? You need a payload to measure the atmosphere, a way to monitor and track that payload, and a way to get it up high above Earth's surface. First, we'll meet college participatory scientists from the University of North Florida who will show us how they are addressing the first of these, payload and tracking.
This is our student payload box. In here we have all of our electronics and where the batteries go, and the electronics are connected to a linear actuator, which after a timer of 90 minutes, it's going to go off and push this resin up into, it's hard to see, but a 3D printed element that's filled with cavities. So the idea is that the resin will go into these cavities and heal the 3D printed part.
This is our main way of tracking the balloon from the ground station itself. We do have the Montana website, but this is what actually tracks it. So when we set this up, we first initialize it to see the sun, and then once we start tracking our payload, this will reposition itself to aim at the balloon at all times, our position, velocity, and other data that we want to send back. So this is what's collecting that data. Notice it takes a lot less, like hardware you can say compared to this. This has this big box plugged in everywhere. This doesn't need that steady live stream, so this doesn't need to move at all.
Next, a team from the South Dakota School of Mines and Technology shows us how they plan to get those payloads 75,000 feet above the Earth using high-altitude balloons. It's 2 weeks before the eclipse, and the participatory scientists are launching test balloons to familiarize themselves with their equipment.
We have different teams, different groups that work together towards a larger goal. Be it somebody working on software, somebody working on hardware, the balloon team, the ground station team, and how everybody has their own goals, their own objectives within that group, and then pulling it back in.
Equipment on the balloons will either live stream the moon's shadow on the Earth, observe atmospheric phenomena, or conduct individually designed experiments.
They want to take imaging of the shadow of the moon as it goes over the Earth, as well as taking additional atmospheric measurements during that time. There's a significant temperature drop, and so that's something you can measure and record how that affects the atmospheric temperatures during those events.
Today is a dress rehearsal for the real thing.
The venting system, what that's set up to do is to release some helium, so we're able to just float at 75,000 feet. Otherwise, it would just continue to go up into the atmosphere until the balloon would burst. But in order to bring the balloon down, then there's a cut down system that'll cut the balloon away.
But while filling the balloon, something goes wrong.
During our filling process, the cut down system initiated, and we saw the balloon fly away.
And it turns out that the 5-hour timer had completed, and at that point it had activated a cut down system, which ended up releasing the balloon early before we had even started to launch.
That's the main thing. You learn from your failures just as well as your successes.
Total Eclipse Day, April 8th, 2024, has finally arrived. But before we see how the South Dakota team's balloon launch goes, we'll check in on another eclipse project, known as Citizen CATE 2024, which was funded by both NASA and the National Science Foundation. The 35 teams were each selected from communities near locations along the path of totality. They've received specialized telescopes and training in exchange for their participation. Let's join a team in Arkansas, excitedly preparing just a few hours before the eclipse.
CATE 2024 is a project where we're going to point this telescope at the sun and try to see what's going on in the atmosphere of the sun rather than the photosphere, the body of the sun.
They're recording the entire eclipse, the totality, so that they can study the corona and like the magnetic reconnectivity and the solar winds and then all that good stuff.
Because of how bright the sun is, the only time that we can actually see the atmosphere of the sun is during a total solar eclipse. It just so happens that the moon is the right size and the right distance from Earth, that when it goes in front of the sun, it perfectly blocks out that photosphere and we can see the atmosphere. The main focus of this project is to study the magnetic fields of the sun and how they cause that atmosphere around the sun, to the corona, to heat up. So we're hoping that we see something going on with the magnetic field while it's more active that will tell us why that heating up is happening.
As the eclipse begins, the team monitors their equipment, making sure everything is working properly.
Right now we are in the beginnings of the partial coverage, and we've got our telescope aligned up with the sun, and we are starting to see the moon come across. That's the moon coming across the sun. We've got a sunspot right here in the middle, but that's the moon. And if you watch, it's gonna creep further and further over the more time that passes. And we're gonna keep watching it until it's totally covered.
Within an hour, the moon covers the entire disk of the sun, allowing the corona to be seen.
We have a tiny little sliver.
That's totality.
All right.
Holy cow! Wow! Look at that! Wow! Come on, camera.
Look at it.
During totality, the telescope rapidly takes pictures with a specialized polarizing filter that provides valuable information about the sun's beautiful and intriguing corona.
5, 4, 3, 2, 1.
Meanwhile, the Florida team launched 2 balloons from Little Rock, Arkansas, and the South Dakota team launched their balloons from Sulphur Springs, Texas, in the path of totality. And the cut-down system worked perfectly. The data gathered by the balloons launched by 53 participating teams is being used by scientists studying Earth's atmosphere. Similarly, the data from the Citizen CATE 2024 project is being analyzed to discover motions and structure in the sun's corona.
This is our first image of the corona that we took using the software and the camera during the eclipse. So we've got our first HDR image. It's amazing. Cool, yeah. Looking at the corona.
The polarized images of the sun's corona recorded from Earth by Citizen CATE 2024 are similar to wide-field images now being taken in space by the NASA Punch mission, featured in the previous episode of Science Through Shadows. Both are helping us to better understand the sun's corona and space weather. So how can someone interested in science get involved with projects like these?
Ask questions. There are so many opportunities out there to be a part of this type of science and this type of engineering that if you have even the slightest interest to look for it and to find it and to experience it.
Really seek out any of the design opportunities that you can. Really get involved as much as possible. If you can get yourself involved and into the things that you're interested in, good things will happen for you. So like, don't be scared to really go for things and just throw yourself into it.
If you're interested in any kind of STEM, look for opportunities. There are opportunities out there at a lot of universities for high school students.
Just get involved. It's going to give you experiences beyond what you learn in the classroom, and that's going to help you out in your career path no matter which way you go. And so it'll be something you can add to your resume, and just all the experiences you have going forward into your future.
Here's a list of other participatory science projects that focused on the annular eclipse of 2023 and the total eclipse of 2024. And participatory science isn't just for eclipses. Here are projects in many other fields. We invite you to follow your passion and participate in NASA science.